to a diverse group of carbohydrates. As humans, we lack the digestive enzyme required to break down fiber, meaning we cannot digest it. It's because of this, we see fiber travel the majority of the digestive tract largely unchanged. In this video, we're going to figuratively break down fiber. Now to start, there are two formal classifications of fiber. There's dietary, which is found naturally in food, and industrial, which is extracted, isolated, and later added into processed foods. And we can also classify fiber based on its functional abilities or its health effects. And this is going to be of far greater relevance for Kin 334. So we can classify fiber based on its solubility to start. And by this, we mean its ability to dissolve in water. Based on this classification, fiber can either be soluble or insoluble. Soluble fiber blends with water in the gut, forming gel-like substances. It can reduce spikes in blood sugar and has various benefits for metabolic health. Insoluble fiber, on the other hand, does not blend with water and passes through the digestive system mostly intact. Insoluble fiber is mostly beneficial as a bulking agent, and this helps to speed the passage of food through the gut. Soluble fibers include things like gums, pectins, psyllium, beta-glucans, and many others. Insoluble fibers include lignin and cellulose. Another way we can categorize fiber is its fermentability. Within each of our bodies, we are housing over 300 trillion live bacteria within the gut, and this is mainly found in the large intestine. These bacteria comprise the gut microbiome and play an integral role related to weight management, blood sugar control, immunity, brain function, and even mental health. Because we as humans cannot digest fiber, we are reliant on the gut microbiota to do the work for us. These friendly gut bacteria are able to anaerobically break down certain fiber molecules through a chemical process known as fermentation. This process leads to the fermentation of fiber and the ability to use fiber as a fuel. Most fermentable fibers are soluble, but some insoluble fibers can also go through the process. Fermentable fibers include pectins, beta-glucans, guar gum, inulin, and oligofructose. And the best whole food sources of fermentable fibers tend to be found in beans and legumes. A serving of 1 cup often provides up to 50% of the daily recommended intake of fiber. And just because fermentable fibers can result in fuel production, one of the byproducts we have to be cognizant of is in the fermentation process is gas. And this is why foods high in fermentable fiber can often cause flatulence and stomach discomfort, especially if you're not used to eating a lot of fiber in your daily diet. The final way we can categorize fiber is based on its viscosity. Now, some types of soluble fiber form a thick gel when they blend with water, and these are known as viscous fibers. When you eat a viscous fiber, it forms a gel-like substance that tends to sit in your gut. This leads to slowing the digestion and absorption of nutrients, which prolongs the feeling of fullness and a reduced appetite. These effects are one of the reasons why viscous fibers have been found to reduce food intake and actually cause weight loss. And these outcomes are also very well supported by the literature. Viscous fibers include glucomannan, beta-glucans, pectins, guar gum, and psyllium. Good whole food sources include legumes, asparagus, Brussels sprouts, oats, and flax seeds.